Hi, everybody. How's everybody doing? Hope everybody's having a good day. Okay, today is Tuesday the 7th, April 7th. A couple pieces of information before we get started. One, don't forget to sign in for attendance. Go on Infinite Campus and don't forget to check your attendance. Okay, that's important. Make sure you do that. Two, make sure you fill out the survey. I know a lot of you are seniors, and they're sending out a survey. The school is talking about graduation. Okay, so make sure when you get that, they want to see when we should have graduation, see how the whole calendar is going, and what people want. So when you get that survey, make sure you're aware of that. Juniors, those juniors out there, remember next week we're still having an SAT practice session for all juniors. You'll get more information from your counselor on that too. So those are the little pieces of information that are coming out right now. I hope you're having a good day. Why don't we get started? Also, don't forget to post in the comments, say something if you're having a question, or send me an email, send something as we go through it. Okay? So let's take a look. Here was from yesterday. Okay, there's our document. Here's where we left off yesterday. We were talking about exponentials. Okay, now exponentials, that's different. Okay, that's not linear. Okay, because remember linear, it goes up or down by adding or subtracting. Okay, remember linear goes up and down by adding and subtracting. This is how you can remember it. Linear is adding or subtracting, whereas exponentials goes up or down by multiplying or dividing. Okay, multiplying or dividing. For example, let's take a look at this. How do I get from 3 to 6? I times 2. I'm multiplying. Times 2. Times 2. You see? I'm increasing by multiplying by 2 every time. So right here, when I times 2, that's 96. You see, we're not adding or subtracting, we're multiplying there. Okay, so how do you evaluate it? Remember, you get your calculator out, and let's look where the buttons are, just reviewing from yesterday. 3 times 2. Now you got to look for the 2, the exponential button. Our exponential button here is right there above the divide sign. That makes a little exponent right there, right above the divide sign, and to the 0. And the calculator says 3, exactly what our table said. Let's try it again. 3 times 2 to the first, and the calculator says 6, exactly what our table said. You see how you type those into your calculator? 3 times 2 to the second, it says 12. That's what the calculator is saying. Okay, does that make sense? Okay, does everybody see that? Here, let's get rid of this. We probably don't need to block our view here. All right. Everybody see what we're saying? That's how you do it. Okay. So what did you notice about the output above that you got from example 1? Well, the output, it doubles. That's where the times 2 came in, doubles every time. That's where the times 2 comes in. Okay? That's what they're looking for there. Okay, now let's look at a word problem here. Let's look at a situation. Okay, the relation between the time lapse and the number of bacteria can be described by this function. That same equation when we're evaluating it, just now we're making a function out of it. This leads us to a new family of functions. Here's the definition. Here's the most important thing. It's an exponential function. An exponential function is a function whose equation can be put in this form. We'll see this on the calculator. So multiple a times b to the x. Now here's the conditions. A cannot be 0. Okay, it doesn't do anything. 0 times anything is 0, so that wouldn't make any sense. B is positive. Okay, it's positive. You can't use an exponent when it's negative. Okay, I'm not saying x. X could be negative, x could be positive. We're just saying b, this base right there, has to be positive, and B cannot be 1. Okay, those are the rules. One more time. A, this number in front, can't be 0. Okay, B has to be positive. You see that? B has to be positive. Okay, so they can't have -5 to the third or something like that. It can't be like that. But B can't be 1, because think about it. 1 to the 5th, 1 to the 9th, 1 to the 100th is always 1. That doesn't do anything. So those are the conditions for exponentials. Okay, so look at the table above. Describe the constant A and B. All right, let's look at our equation here. Okay, here is A is 3. Remember how we do y equals mx plus b, or we do ax squared plus bx plus c? Well, we have a's and b's on this one too. A is what's not to the exponent, and b is what's being raised to the exponent. You see? A is not to the exponent, and b is what is to the exponent. Okay? Does that make sense? How we feeling there? Okay, so let's do a couple examples. Okay, next page it says compare linear functions to exponents. That's what we're talking about today. How does this change? This adds to. You see, plus 2. Okay, plus 2. So that's how I know this is linear. And remember, linear is y equals mx plus b. You see, so now we should be able to figure this out. This is old business right here. That change is the slope. That's the m part. So y equals 2. And the b is the y-intercept. B is the y-intercept, 3. Okay, you see that? Okay, now that's the same type of thing. Okay, for this one, the b is the same b as, okay, watch it here, y equals mx plus b, the y-intercept and the slope. Here, this is times 2. Times 2. Times 2. You see that? So the times 2, as we said from the last page, you see from the last page, the times 2 is the b. See, they're using different letters here. So b is times 2. That's not the same b as that. That's not the y-intercept. That's the b that's being taken to the exponent. Okay? Whereas the 0 is the a. A is 3. You see that right there? Okay, when x is equal to 0, that's how you get the a. See, that's a little different. That's what we got to pay attention to again. Let me go through that one more time. Okay, for linear, this change right here, plus 2, plus 2, plus 2, that's m. Let me change colors here. Okay, this change right here is m. Whereas this change right here is b for exponents. Okay, because remember, exponents is y equals a times b to the x. See how that's different? See how these equations are different? And they're using the same letters. We only have 26 letters we could use. So they're using the same letters here. So the b is that part. And then the y-intercept, let me change colors. Let's do green. Okay, the y-intercept, this is the b for y equals mx plus b. Whereas this one, let me color code it. This is our a. So a is 3. A is 3, and the b is the 2. So that's how you get that equation. Okay, here's where you should pause the video and see if that made sense to you. And if not, you post a question or email me or Mr. Byrne or somebody and ask a question about that, because that's the most important thing. Linear, we know already. Linear, we know how to find m, that's the change, and we know how to find b, that's the y-intercept. Okay, I don't want you to get confused, because the b is the change on exponential. That's the letter we use for change, the change. And the y-intercept is a for exponential. Okay, so you got to get those in the right spot. That's the formula that they use. Okay, let's practice this again. Okay, so take a look at this situation here. Okay, now, okay, here comes another situation. Every point in the input-output table is a solution to the equation. And every solution to the equation is on the graph. Okay, so for example, let's take a look at these numbers here. Remember, we could always work backwards. If this is times 2, this is times 2, this is times 2. Okay, so if we work backwards, we divide by 2. Okay, so if this is going this way, we're dividing by 2. Dividing by 2 to work backwards from it. Dividing by 2. For if I'm going backwards in the direction, so notice what I'm doing. I'll take 3 divided by 2, and I get 1.5, or 3/2. 1.5. If I do another divide by 2, I get 0.75, or 3/4. If I do another divide by 2, I get 0.375, or let me make that a fraction, math. Remember how we did it, math, fraction, and I get 3/8. You see what I mean? Working backwards, I divide by 2. So if I start plotting that, the decimals are helping me here. Let's start at 3. That's all the way off the graph, all the way up here. 2, close. Maybe I could try to wing it and say it's right about there. 1 is 6. 0 is 3. -1 is 1.5. Here's where we start getting some decimals. -2 is 0.75. -3 is less than half. So I'm going to go less than half on that. And notice how exponentials look. Okay, be careful here. You never, ever, ever highlight, never cross. When you're just drawing a regular old exponential, you never cross. You go here, and you come up, and then you shoot up like that. That's what an exponential graph looks like. So never cross the x-axis, because that x-axis is called a horizontal asymptote. That's new. Okay, that's a border. Okay, that's the floor. You cannot pass that. Okay, that's what a horizontal asymptote is. We're going to call it end behavior, but you cannot pass through that. You're stuck there. Okay, so what does that mean? Okay, identify the x-intercepts. Okay, never, none. It never crosses the x-axis. Identify the y-intercepts. Okay, y-intercept, that's the traditional, is 3. And like I said, that horizontal asymptote is the floor. It's y equals something. And what does y equal? 0. All right, let's go through that one more time. Okay, I just plotted these points. I took all these points, I put them on the graph. This is what my graph looked like. Okay, and some of the really important points are, as always, the y-intercept. Y-intercept is always a biggie. The y-intercept's an important point. Okay, and then the new idea here, is a horizontal asymptote. That's how you say it. And remember, an asymptote is a border, a floor. You cannot pass that. Okay, so it comes here. Think of a. It's coming down, but it can't. It's got to go one way or the other, and it goes that way, because it just keep going, looking for a way to cross that line, and it never can cross that line. Okay, it's a wall, a floor, if you want to think of it like that. That's what an asymptote is. So it never crosses the x-axis. The y-intercept, yeah, that's easy. That's where b is equal to, or I should say that's the y-intercept. We called it a, remember. And then the horizontal asymptote is y equals 0. Horizontal line right there that you can't cross. That's what they're talking about right there. All right, as units of values become more and more negative, what happens to the output? Okay, see how it becomes smaller and smaller. Okay, but it never hits 0. So it's getting really close to 0. Okay, so what happens to the output? The output gets close to 0. Will it ever reach 0? No. Maybe you could say at infinity. Maybe you want to say it. Maybe when I get to infinity, can you see that? When I get to infinity, it's going to reach 0, but it doesn't reach 0. Okay, it just gets closer and closer. Let's go the other way. As the input values become more and more positive, what happens? It just gets bigger and bigger. Okay, so it doesn't get close to 0. It goes the other direction. It gets bigger and bigger and bigger. You see? As it goes positive, it just keeps getting more and more and more and more. Will the output ever reach 1,000? Sure. Will it reach 1,000,000? Sure. Will it reach 1,000,000,000? Sure. What does it go to? It goes to infinity. So it'll reach 1,000, and we'll work on how to get there, how to calculate when it hits 1,000, and we could go doubling. Okay, let's see when it hits 1,000. Okay, when we were at 3, let me start off. We were at 3, and we said times 2. Okay, so now when we plug in 1 times 2, that's the value. Take a look at it. That's 2, 3, 4. See, it's doubling. 5, 6, 7, 8, 9. Well, there you go. Somewhere between 8 and 9, it crosses 1,000 because it just doubles every time. See how we did that? That's kind of fun. All right, let's finish off. One more example. One more example for today. Let's look at this one. Okay, they gave us some little patterns. So let's see what's happening here. Notice this is a fraction now, 1/2. Let's see what happens there. Okay, what's our progress? To go that way, it's getting smaller. So it's not subtracting, remember. Exponents are multiplying and dividing. Since it's getting smaller, we're dividing. 4 divided by 2. 2 divided by 2. So going this way is dividing. You notice how the fraction's 1/2. It isn't dividing by 2, saying times 1/2. So if we divide by 2, I got 0.5, or 1/2. Divide by another 2, I got 0.25, or 1/4. Oh, wait, did I miss one? No, I'm good. Divide by another 2, I got 0.125, or 1/8. And divide by another 2, I got 1/16. I don't know what that fraction is. 0.125 divided by 2. 0.0625. Notice, getting smaller and smaller and smaller and smaller, but never crossing 0. Okay, and which way? This way. If this is dividing by 2, going this way is times 2. So this is 8. This is 16. This is 32. You see? Times 2 going that way. So notice how this graph, let's plot this. At 0, it's 4. At 1, it's 2. At 2, it's 1. At 3, it's 0.5. That's 4. See how it's getting smaller and smaller and smaller and smaller, but never crossing 0. And then we go back this way. At -1 was 8. At -2 was 16 all the way up here, and we're running out of room, so let's show this graph. Doesn't that graph look very similar to this graph? You see those two graphs right there? So this time, as the inputs get more and more negative, this gets bigger. See how it's backwards? And bigger and bigger. Will it ever reach 1,000? Sure, we could do that. But what happens as it goes to positive? This time, as it's going to positive, it gets closer to 0 as it's going to positive. And will it ever reach 0? No, it will never reach 0. You see how that's the complete opposite of this one. Whereas this one, see how when this one, as it becomes negative, it goes to 0. And if this one, as it becomes negative, gets bigger and bigger and bigger. Whereas this one, as it gets positive, gets bigger and bigger and bigger. See how they're opposites each other? So the difference is, back to the first sheet. Okay, the difference is the B right here. You see how, the definition, the B. Okay, if B is between 0 and 1, in other words, a fraction. If B is a fraction, like 1/2, take a look. If B is a fraction like this one, you see how B was 1/2 right there? If B is a fraction, then it looks like this. And the word we use is exponential decay. Okay, whereas if b is bigger than 1, it looks like this. And that's called exponential growth. Okay, think about it. With linear, we had the same thing with linear. Linear, we had increasing and we had decreasing. And it was all based off of m. If m is positive, linear is increasing. If m is negative, linear is decreasing. Well, exponential is the same thing. It's based off of the b. Okay? If b is between 0 and 1, remember the rule, b has to be positive. So if b is between 0 and 1, it looks like this. It's exponential decay. Instead of increasing and decreasing, we say decay and growth. This is decaying, that's going smaller. This is growing, it's getting bigger. So not positives and negatives anymore like linear. It's between 0 and 1, and b is greater than 1. That's what they're trying to talk about on the worksheet here. Here, b was 2. Can you see that? B was 2, and it's exponential growth. And so when it grows, on the negative side, it goes to 0. On the positive side, it goes to infinity. Here, b was 1/2. If b is 1/2, that's exponential decay. On the positive side, on the negative side, it goes bigger and bigger and bigger. It goes to infinity. On the negative side, it goes to 0. Okay? That's the idea that we're trying to get to. Okay, so what I want you to do, okay, is a couple things. Remember, take a look. Remember, first of all, you have 3 from last week. We got to turn in our assignments from last week. You got 3 assignments from last week, okay? You have the worksheet from last week, Monday, Tuesday, Wednesday. And then don't forget, on Friday, we had the quiz. So you got to have those turned in. I'm putting the grades in. I'm putting stuff online. And so make sure you turn all those in. I'm just keeping track, and then I'll keep updating the grades as people turn that kind of stuff in. This week, there's 3 more sheets, and then we'll have a quiz on Thursday. Remember, no school on Friday. Okay, so we'll have these 3 sheets are due. We did 2 of them together already, so really, it's like all you got to do is work through it with me and then turn it in, and then we'll have a quiz on Thursday. Okay? Hope everybody's having a good day. Don't forget to take attendance for yourself, and don't forget to get your work done. Thanks a lot, everybody.